Welcome to The Explainer. Today, we're totally bypassing all those AI buzzwords you hear every single day and diving straight into the physical and financial realities of the global AI boom. We're talking actual infrastructure and the massive mountains of cash making it all happen. To really wrap our heads around the sheer scale of tech right now, we gotta look at a pretty crazy contrast. Think about Wikipedia. It's this massive foundational pillar of the internet, right? But it relies on just 2% of its users donating an average of exactly $2.75 just to keep humanity's free knowledge alive. It's entirely nonprofit, literally kept afloat by regular people chipping in a few bucks. But then you flip to the completely opposite end of the spectrum. Tech giants are pouring billions, and I mean billions with a B, into an unprecedented AI infrastructure build-out. Alphabet is massively ramping up its spending, Microsoft is announcing just an absolute glut of new data centers, and top tech players are even forming entirely new industry groups just to build next-generation AI chips. The sheer volume of capital flowing into this space right now, it's honestly unlike anything we've ever seen in modern tech history. So that brings us to the big question for this explainer. Where exactly are all these billions going? We're going to follow the money today to see what this staggering investment actually buys, moving from those macro corporate headlines right down to the microarchitecture of the tech itself. All right, here's our roadmap. We're covering the two internets, the AI arms race, the AI five-layer cake, simulating reality, the autonomous era, and finally, the true cost of AI. Let's dive in and explore this massive hardware and software ecosystem that's absorbing all this global wealth. Starting with Section 1, the two internets, from $2.75 to billions. Just keep that extreme financial disparity in the back of your mind as we look at the hardware being built today. Moving right along to Section 2, the AI arms race, talent, and tech. Let's see how this crazy spending fuels an intense, incredibly competitive sprint. Because look, this spending isn't just going towards server racks and cooling fans. As industry analysts are pointing out, AI's talent arms race is starting to look a lot like pro sports. It's this fierce, incredibly high-priced battle to draft the world's top engineering minds. Companies like Alphabet and rising players like DeepSeek, they are aggressively competing to lock down the human capital needed to build the future. When billions of dollars are on the line, the people writing the code literally become the most valuable assets on the board. And when it comes to the actual hardware these genius engineers are fighting over, one company is totally dominating the foundation. A staggering 81% of the world's top 500 supercomputers are powered by NVIDIA technologies. 81%. That is basically a virtual monopoly on the high-performance computing you need to train the next generation of AI. So to truly understand where the money goes and how this dominance actually operates, we have to look at how NVIDIA structures this whole ecosystem, which brings us to Section 3, the AI five-layer cake. This concept brilliantly illustrates that AI isn't just some simple chatbot floating up in the cloud. It is a highly complex five-layer cake stacking physical infrastructure all the way up to specialized apps. At the base, you've got the hardware, the GPUs, and those massive data centers. Right above that sits system software, like NVIDIA's CUDA. Then come the frameworks and microservices developers use to actually build things. On top of those are the foundational AI models themselves. Think Nemutron and Cosmos. And finally, sitting at the very top, you have the specific end-user applications. When companies are dropping billions, they're heavily investing in every single slice of this cake. Ultimately, when you use an AI tool on your phone, you're just tasting the icing. But these tech giants, they are paying for the whole cake. And right at the very top of that cake sits something called agentic AI. These are systems explicitly designed to reason, plan, and autonomously execute complex tasks. Think of it less like a super smart search engine and more like an automated intern. This tech is being deployed right now to handle 24/7 autonomous workflows in highly complex fields like telecommunications and life sciences. It's software that doesn't just give you an answer, it actively solves multi-step problems for you. All right, Section 4, simulating reality. Let's look at how this crazy layered computing power gets applied to the actual physical world around us. This introduces a wild concept called the digital twin. A digital twin is basically a large-scale, physically based simulation. Companies are using platforms like NVIDIA's Omniverse to create these highly accurate digital replicas of real things. It lets them simulate actual real-world physics to optimize everything from e-commerce shoe designs to the layout of brand new, multi-billion-dollar semiconductor factories, like the ones built by TSMC. You can literally test run your factory in the digital world before you ever pour a single ounce of concrete in the physical one. But here's the catch. To run these massive, physically accurate simulations, you need an unbelievable amount of horsepower. Billions are being spent right now on exascale supercomputers. These are machines capable of a billion calculations per second. A prime example is Jupiter, which is Europe's first exascale supercomputer. Systems like this are specifically designed to unlock entirely new scientific discoveries by simulating incredibly complex phenomena. We're talking advancing climate modeling, brain mapping, and 6G network research. Which leads us to Section 5, the autonomous era, AI on the move. Because this technological arms race isn't just confined to dark server farms, it is quite literally being embedded directly into the vehicles we drive every single day. Automakers are now cramming massive reasoning models right into cars. Take the Alpamayo 2 Super, for example. It's a 32 billion parameter reasoning model. And if you think of parameters as sort of artificial synapses making decisions, this thing is purpose-built for level 4 robotaxis. It allows vehicles to independently reason through completely chaotic real-world traffic situations without any human intervention at all. And the world's largest automakers are going all in. They're fully adopting this software stack to turn everyday cars into roaming supercomputers. Mercedes-Benz is integrating the Drive AV and Hollows architecture, which is already helping them earn top safety awards. Hyundai and Kia are deeply integrating next-gen tech into their software-defined vehicles. And manufacturers like BYD and Geely, they're already building entire Level 4 robotaxi fleets on this exact infrastructure. Finally, we hit Section 6, the true cost of AI. As much as we can marvel at these incredible technological leaps, we have to impartially look at the very real physical and economic toll of this rapidly expanding ecosystem. There is a really stark tension happening right now. On one hand, you've got corporate messaging heavily emphasizing sustainable computing, pushing for green supercomputing and energy efficiency. Sounds great, right? But on the other hand, you have the physical reality. Industry observers are reporting that these massive new data centers required for AI tools are, in some places, running on fracked gas and requiring huge swaths of bulldozed land in places like Texas. The physical footprint of that 5-layer cake is very, very real. And alongside those physical costs, there are mounting financial realities. While the tech is undeniably impressive, financial analysts are waving some red flags. They're noting that the underlying business models and margins in the AI space are in a state of rapid, unpredictable flux. Infrastructure challenges are piling up fast, and the profit margins of heavily funded AI startups are being intensely scrutinized by Wall Street right now. This leads to a really fundamental question that's currently echoing through the whole tech industry. As one headline recently put it regarding a new test for AI labs, are you even trying to make money? As models get cheaper and more open source, the path to actually recouping these multi-billion-dollar investments becomes increasingly complicated. So that brings us to the end of our explainer, and we want to leave you with this to consider. When the multi-billion-dollar infrastructure build-out completely outpaces actual profitable business models, what happens next? Will the eventual widespread applications of this 5-layer cake justify the astronomical costs we're seeing today? Or is this incredible arms race headed for a dramatic economic correction? It really is the multi-billion-dollar question that's going to define the next decade of tech. Thanks for joining us for this explainer.